How's everyone doing?
Good.
Dad?
Good, I hope.
Living.
All right, we still have another minute or so and then we'll get started. Everyone have a good weekend? Y'all look excited to be here. We'll learn some new stuff today. Has nothing whatsoever to do with JavaScript. Like, wait a minute. We're actually going to take 2 days to learn this stuff, but that's okay. It's 1:30. Let's get started.
Oh, quick question.
Yes.
So I am going to be heading back home tomorrow,
Okay.
and I will miss a good chunk of class.
The cool thing is every one of these classes is recorded.
Yes, but will you still be taking attendance?
Yeah, I will be, but
Okay. I'm just letting you know ahead of time that I will miss a chunk of the class, but I will possibly get on at like the last couple minutes or so.
that's okay.
Okay.
So, in truth, a lot of what we're doing, well, I'll tell you, well, I can tell you now, class has started. We're going to be talking about regular expressions. Any of you done regular expressions before? Joe, you have? Or you're just, okay, cool. Regular expressions are one of those things that every programmer learns how to do. And 99% of them completely forget until the next time they have to do it. Unless they're doing them fairly regularly. But so far, Newmont has not taught you all how to do these, so I'm going to teach you. You may end up using them in other classes. Does anyone know what regular expressions are for? No one's real sure. They're used for pattern recognition, okay? Identifying patterns. And they're really cool. They might not seem like it in the beginning. Chapter 7 in the book talks a lot about regular expressions. It just does a terrible job at it. So I'm going to teach you how to do regular expressions. It'll probably take us a class and a half, maybe 2 classes to do it right. But by the time we're done, you're going to be like, oh, I love regular expressions. I'm not afraid of them. They are awesome. And you're going to see all sorts of times when you can get away with using them and they will be great. Cool? Excellent. So before we get into regular expressions, we probably need some fantastic resource for learning about regular expressions. And so let me share my screen. And I need to set my screen up so that I can see chat rooms and everything else. Joe, do you remember how to use regular expressions? I know you were saying that you've used them before. Do you remember the syntax? Cool. All right. So I told you we needed a fantastic resource for learning regular expressions. So I'll send you to tpady.com, mainly because it has a regex section right there that talks all about regular expressions. And so I'm going to click on this and hit the basics. And initially, we're not going to really talk about using it in JavaScript. Regular expressions are usable in almost any language. There are certain commands or certain syntax that you would use with it, but in general, what I'm going to teach you of regular expressions, you can use in Java, C#, C++, JavaScript, Python, Ruby, you name it. Okay, so it's pattern recognition, it's beautiful. And here's the most basic of all. You can usually identify that you're dealing with regular expressions because you'll see stuff between slashes. And here's a real simple regular expression. It is a regular expression looking to match the word the. And I've got, with all of these examples, I have several different tools to work with. Like we can go to this try it out. And this takes us to regex101.com. And here's the regular expression. You can see there's a slash here and a slash here. And here's the word the. And it goes and it looks at this text string. And it matched the word the. Now you'll notice it didn't get the first one. Why didn't it get the first one?
Case sensitive.
It is case sensitive. That's exactly right. But it didn't get this one either. It's because by default, without putting any flags in there, it will look for the first match that it finds. There are ways to make it go through and look and find all of the matches, and we'll talk about that eventually. But this is the very first the that perfectly matches our regular expression. Make sense? Cool. And you know, if I changed this and I said dog, oh, look, it matched dog. Or if I said find D, and it found the first letter D. And then the next tool that I use in all of these examples is view diagram. And this is a wonderful little website that actually diagrams a regular expression. And so we can see here's the start of the regular expression. It's working for the word the, and here's the end of the expression. The diagrams are going to get much more complex, but I want to show you the diagrams because if you ever decide to go back and look at chapter 7, they use regular expression diagrams, and understanding how to read those will be helpful if you decide to tear apart that terrible chapter. Okay. So that is the most basic example of a regular expression. And we're going to go through all kinds of other things. Next thing we're going to talk about is character classes. So classes, your character classes are defined by these brackets. And when you create a character class within your slashes, what it says is it is looking for a single character. And that character can be any one of these. Does that make sense? So
It won't try to look for a word like that, but it'll just search for the letters?
Yes, because it's a character class. It's inside these brackets.
Oh, okay.
Okay.
I got
it. Regular expressions get really complex and really ugly quickly. Let me show you what I mean before we move on. I've got several examples. Some of these are more complex than others. Regular expressions are ugly to read if you don't know what you're looking at. That's easy to decipher there, right? Joe's like, no problem, I got this. Or here's a pattern match for US phone numbers. Or IPv4 addresses. Doesn't that look nice and easy to read? By the time we're done, you'll be able to read it. Okay, let's go back to our character classes. I have to go out, I have to start up slowly. Don't get freaked out. It actually isn't that bad if you understand the syntax and what we're doing. All right, so here, yeah, it's looking for a single character that is either a lowercase a, e, I, o, or u. So it's looking for a lowercase vowel. And so if I try this out, it's matching the I. Why is it matching the I?
Because that's the first one it came across.
Because that's the first one it came across. Absolutely. What if I removed the I from here? What would it give me?
E.
Yeah, it would give me that E. Excellent. Cool. You guys get this? Not too bad, right? And if we looked at the diagrams at this level aren't too difficult. So one of A, E, I, O, or U. Okay.
Seems like this is just kind of like Control F, if you know what that is.
For control what? For
Control F when you like can search for a letter.
Oh, yeah. It gets
Kind
more
of
complex.
seems like that's what we're doing.
Yes, but it gets a whole lot more complex.
Okay.
Regular expressions are for full pattern matching. Right now, we're just looking for a single character, but we can do more, and we'll start getting into more complex things in a minute. So here, I've got a character class, and you can use hyphens. So I could say, find me a value from 0 to 9, right? Find me a character from 0 to 9. And if I try that out, it's going to show me the first digit that it finds. And here's a number 1. But I could change this if I wanted to. I could say, find me the first character that's A through F. Or capital A through F. And there isn't a capital letter A through F there, but I could say A through M, and it'll catch this I then. And I look at the diagram, one of 0 through 9. Okay, now we get into something a little more complex. We've got 2 character classes here. So I've scrolled up a bit, so it's not obvious what's going on. Tell me what this is looking for. Don't cheat, just take a look at it with what you know. Each of those character classes is looking for a single character. So tell me what the match is.
Okay, so I guess it's trying to find either a letter A through Z capitalized or not, and 0 to 9.
Yes. So,
but which one would it? So if it finds like the A through Z one, would it still find the 0 through 9 one, since it can only search up one?
So it's searching for the first match within these lines. So it's going to look. It's looking for a letter followed by a number.
Oh, okay.
So if we try this out, so it's finding F3. And this one doesn't work because there's a space. Does that make sense? And if I made this a lowercase f, that would still work. See how we're beginning to get more complex patterns?
Yes, I see. But how would you do it if you wanted to have a space in between, if you wanted to find a combination of letters and numbers with a space between?
So if you wanted to have a space in between, I could just put the space in there. And now this is my match. that make sense?
Yeah.
And if we look at the diagrams are going to begin to get a little more complex here. One of A through Z lowercase, one of A through Z capital, and one of a number. So a letter followed by a number. Okay, we're getting a little more complex. Ignore this G here for the moment. But tell me what that is. Any ideas?
It's going to be looking for GR, and then either if A or E pops up first, and then Y.
Yep. And
So
Ryan's got it right in the chat there. It's looking for either the US or UK versions of the word gray. So either GRAY or GREY. Either's acceptable. Now, this G, if you see a letter after the closing slash, that's what's known as a flag. And this is the global flag. And if you put the global flag in there, it will find every instance of a pattern match. So it doesn't stop at the first one. So here, I've got this and I've got the global flag turned on. And so it found both the GRAY and the GREY.
Okay, question then.
Yes.
If it finds like all of them, would it just find those two, and then when like another gray comes up, will it also highlight those, or just highlight the first ones? Oh, okay.
Global means it's going to find every single match instance. And you'll notice it's counting them up here.
So it won't just find one, it would find all of them.
That's correct.
Okay. All right.
Even if it's uppercased?
Ah, so what will it do if I do uppercase? What do you think?
Oh, wait, it won't because, oh, actually, it's global. I don't know. But the first letters, the GR and the Y, are lowercase.
Right. Now, there is a flag, we'll talk about it later, an I flag, which makes it case insensitive. So then it'll find both the upper and lowercase. And if we look at the diagram here, it's going to be GR. I've got a global flag, either A or E, followed by Y. What would happen if I wrote gray GRAEY? Would it find that as a match? So if I wrote, now that's not a match because inside, remember, if it's in brackets, it's only looking for one character in those brackets. So I have to get rid of one of those to make the match. Okay. So if you have the caret, that little point up thing there, if you have a caret at the beginning of your class, it will match anything except what you've put in the class. It's kind of like a not, right? So this is getting all the consonants. Well, it's getting more than the consonants. It's also getting the spaces in there too, because it's anything that is not inside that class. And if I wanted to just get the vowels, I'd get rid of the caret there. Make sense? And the diagram for that is none of these. Okay. Now we're going to talk about quantifiers. Quantifiers are cool and they are used all the time. So here are the quantifiers that we need to know about. Question mark. match 0 or 1 times. This will make more sense in a minute. When you put a plus, that means you're going to match 1 or more times. A star, match 0 or more times. Then in curly braces, a 2, match 2 times. 2 comma 4, match 2 to 4 times. 2 comma 2 or more times, and comma 2, match 0 to 2 times. Okay. Now, these quantifiers refer to the thing directly before them. So the question mark is match 0 or 1 times. So here, this is 0 or 1 times. It's referring to the U. Tell me
Okay,
what that's.
so it won't refer to U, O, M, R, and A.
Nope,
It just the U.
just the U. And so
Okay,
basically, oh, go
so
ahead.
it's whatever is on the left side of it, and not the
Yes.
right, or
Yes.
okay. Let me make sure.
So what it's doing there is saying match the U 0 or 1 time. So either the U is there or not. It doesn't matter. It's optional. It's kind of like saying, well, ultimately it's saying US spelling of armor or European version of armor. Either is acceptable. So the U is optional because it's got the question mark. Make sense? Kind of cool? Kind of see how this can get ugly? It's not bad if you know how to read it. It's not intuitive. No one just looks at a regular expression without understanding how they work and suddenly says, oh, I get it. And so it's interesting how they do the diagram for this. So here's the beginning, definitely ARMO, and either a U or not, followed by an R. Does that make sense how that works? Okay. The plus modifier, match 1 or more times. So without reading what I did here, what would this mean? Just taking a look at S plus. So
Anything that contains S, I guess.
yeah, anything that contains S or even lots of S's.
Okay.
But you'll notice because it's an S plus, it's 1 or more times. I've got lots of S's here, lots of lowercase S's here, but it makes 4 matches because this is a match. This is 1 match, even though it has 2 S's. This is 1 match, and this is 1 match because it's 1 or more times. And the diagram for that, here's an S, and you can either go here or you can go around in a loop as many times as you want. Does the diagram help? Maybe a little? They help a lot when you get into more complex things, in my opinion. Okay. So here we've got another plus. What is this saying? What is that going to match?
Any length of numbers?
Any length of numbers. And if there's anything in between the numbers, it breaks it up and those become separate matches. And the diagram is how you sort of expect there. One of these, but you can go through that loop. multiple times. Okay. So the asterisks match 0 or more times. Tell me what I've got, what I have to do here to match that.
You're looking for an A, B, or C with or without numbers?
And how many numbers?
As many as you want.
Yep. Why isn't this one a match?
There's no D
Because
in the first brackets.
Yep. That's exactly right. Okay. And you can look at that diagram. And it either has none, or it has one, or as many times as you want on the numbers. Okay. How about this one? Do you remember what it is if we see a number inside of curly braces?
Is it how many times you're supposed to like, or I guess so it's 0 to 9, right? So any number, and then, so is it any 3 numbers globally?
Yes. So it matches groups of 3.
Hmm.
And the diagram here is kind of interesting because it definitely has 1, 0 through 9, and then we'll loop through 2 more times, making a total of 3. And then this one, when you do 3, 5, is 3, 4, or 5 digits together. So that's a 3-digit number, it counts. Here's a 4-digit number, that counts. This one is a 6-digit number, so it takes 5 of them and leaves the last one off. That's 5 digits, and that's 4 digits. And you can see the diagram there. 2 through 4 times. Grouping. Grouping, we used parentheses. You can group things together so that you can attach modifiers to them and do other things. So here, this has a question mark. And because we're using grouping, the question mark is referring to everything in this group, not just the character before it. So what would that match? Remember, a question mark is 0 or 1 time. So it's kind of a either or, whether it's there or not. Kai has got it right. Oh, so does Ryan. Either DE or defeated. So DE in decode, both DEs, DE in deflated, or all of defeated. All of those are matches. And to see the diagram of that, definitely has a DE and either nothing or this group feeded. Then we've got the positive look ahead. You can see here, using the question mark equals in the beginning of a group, you can match only what comes before it if what is in the group comes after. So it's not actually matching protect. It matches pro, provided tect is in there. So proceed isn't a match, provide, but because tect is in there, it will match this pro. And if I changed this to vide, then it matches this pro. And you can see it's going to match pro, positive look ahead on tect. There's a negative look ahead too, where you do question mark, exclamation point, where it won't match the pro if it has tect after it. So it will match these. And you can view the diagram there. So we have pro, tect. This is the negative look ahead, so it only will match it so long as tect is not after it. Cool? All right. Now we've got the pipe. The pipe you should be more or less familiar with. Because it works like it does in other programming. The pipe is an or statement. Lions or tigers or bears. So all of those are a match. But apparently no monkeys. Unless, of course, we added monkeys. And maybe got rid of bears. And that diagram is actually fairly predictable. Lions, tigers, or bears. Oh my. Okay. Now we'll mix it up. We'll use the or with grouping. And so when we do that, it's matching up pro if it has tect or vide or seed after it. But it won't do protract or procure because it doesn't have one of these extensions after it. We can see our diagram there. Special characters. This is where it really gets crazy. Okay, by using a backslash in front of certain characters, you can look for different things. Like a backslash n is a line feed, or a backslash t is a tab. So I can try this out. And here, I have a tab. This just looks like a space, but it's not. It's a tab. Now you'll notice it says I have 6 matches. It's because I've got some line feed characters in here. I've hit return. So I've hit it once, twice, 3 times, 4 times. So there are 4 carriage returns plus 2 tabs equals 6 matches. You can look at the diagram, line feed or a tab globally. We have some meta sequences. I kind of hate the way they did these. S is any white space character. They used S because space. But a capital S is any non-white space character, which is kind of difficult to look at because let's face it, lowercase s's and capital S's look a lot alike. D is a digit. A capital D is any non-digit character. Lowercase w is a word character. Capital W is any non-word character. And you're like, what the heck's a word character? Well, let's take a look. So letters are all word characters. Spaces are not. Commas are not. Parens are not. Numbers are word characters, and underscores are word characters. If I
What
change,
about dashes and stuff?
oh, good question. So if I put a dash in there, I'll just put it right here. No, which I've never understood why an underscore is a word character, but a dash is not.
And what about pluses and stuff like that? Those aren't either?
No, none of them.
Okay. All right.
But if I then change that W to a capital W, those are all the non-word characters. Okay. The diagram, word. Okay, let's get a little more complex. Without looking at what I wrote in the page, what is this? What's the first part in brackets? Not seeing in the chat. So what do we call something that's in brackets?
It's either one of those two, like L or 1.
Yeah, that's actually a lowercase l. Sorry,
L.
The font is
L or L.
Yep. So that's a character class with either a capital or lowercase l. So something that starts with L, followed
And
by
the word more time. Word? I know it's like all the words. I'm trying to figure out what the plus is in front of it.
okay.
Like,
All the words that start with L, no matter how many letters after?
Yes,
okay.
because it's one or more matches after it.
Okay.
So words that start with L, capital or lowercase. So all this stuff combines together. Then we have the dot. And the dot is a wild card. And it'll match pretty much anything except a new line. So what is this? We've got a wild card character and then a 5 in curly braces. Any guesses?
Is it just gonna match anything like 5 times?
Yeah, any 5 characters, except for new lines. It didn't get this because there are only 4 here. But if I put a period, oh, look. And we haven't looked at a diagram in a little while. Any character 4 times. Okay, now is where it starts getting ugly to look at. That's the backslash escaping. So characters have meaning, right? When we look at different characters, some of these mean certain things. Like, for instance, if you put something in parentheses, that's a grouping. But what if I want to match something that uses parentheses? Well, then I can put a backslash in front of it. So this has a backslash in front of an open paren and a backslash in front of a closed paren. So these parentheses are not actually grouping. It's looking to use a parenthesis, open and close. And then inside my parentheses, I've got word characters and spaces. Either is fine. And as many of them as I want in parentheses. And so it's now matching things inside parentheses. Cool?
I forgot what that S means.
These are white space characters. So if I got rid of the S, it wouldn't match this because there's space in there. I can put that back. Or since it's a space, I could just put a space. But there are several white space characters, like tabs are considered white space characters. So if there's a tab in there, that will still work. And I could even put in a tab. So do you see how this parenthesis thing works? Or if I put a parenthesis here, maybe I put in a parenthesis plus, or excuse me, a backslash plus there. And that's looking to see if there's a plus in as well, because I used a backslash escape before putting the plus character in. I know it's beginning to look a little atrocious. Regex does look ugly. I know this. But if you learn the different parts, you can learn to read it and write your own. Now, another way that you can do these special characters, if you don't want to use an escape, you can put them inside a class. I kind of find that to be easier to read, but fewer people do it that way. You see how that worked? If you have parens inside a class, it will read it the way that it'll read it as parens, not as a group. And I can look at the diagram for this. Oh, I guess the next one actually shows how to do that. But it's looking for a paren, word or white space as many times as you want, and a closed paren. How are we doing on time? We got a little time left. We might actually get through all the basics here. Anchors. Anchors are fun. So remember, when we have a caret inside of a class, it means not any of these things. But if you have a caret at the beginning of your regex, right after the initial slash, it says that this, whatever regex you're doing, it has to be at the beginning of a line. And the $sign is it has to be at the end of a line. Now, let's not read what this does. Let's see if we can decipher it. So we know that this says this needs to be at the beginning of a line. What's the backslash D mean?
Digit.
It's a digit. How many digits?
Any digits, or as many as you want.
One or more, yeah.
Yeah.
But it must be at least one because it's a plus sign. And then we've got a backslash period. What is that?
Wild card.
So close. Periods are normally used as a wild card, but what if you have a backslash in front of it? Then it's actually a period. That's a backslash escape. So a digit of any length followed by an actual period. And then this next one is the wild card. And how many?
Oh, so is it looking for a decimal?
Yeah, well, it would be, except, so it's looking for a number with a period followed by, what is that period? It doesn't have a backslash in front of it, so it's a wild card. And how many of those?
As many as it wants.
Yes. So it's a number followed by a period, followed by whatever else you want to put after it. It's got to have something, but as much of something as you want. And then I've got two flags here. I've got the G flag and I've got the M flag, and the M is actually a multi-line flag. So not only will it keep looking, it will find all the instances. It will find all the instances on as many lines as you want. So I try this out. And it's basically just looking for numbered items, right? Get rid of the period after this one. Oh, no longer a match.
And if there's something in front of it, right, it won't match.
Well, will it or won't it?
Well, I thought it had to be in the beginning of the line because of that caret.
Excellent, because of the caret. And if we look at the diagram for this thing, oh, that's right. I've got a bad link in there. I got to fix that. All right. So here's the end of line character. Without looking at anything, let's try and figure out what the heck this is doing. So what's that first character in there?
Wild card.
Wild card. How many of them?
Zero or as many as needed.
Yep. Followed by what?
Is it just looking for a semicolon?
Or semicolon or a curly brace?
Or a curly brace?
Open or closed. And it has to be, this semicolon or curly brace has to be at the end of the line. And that's global, multi-line. So let's see what this does. Oh, it's the beginnings of writing an IntelliSense. You forgot your semicolon. That's not a match anymore. Oh, now it is. Oh, this line, it's missing your open curly brace. Oh, that's better. Make sense? So you might be able to imagine that using a whole lot of regular expressions, you could write your own code debugger, right? Can look for appropriate commands and what should go after them. thought I'd do something that maybe you all related to a little bit more, because how often are you looking for different spellings of the word gray? So any character, as many as you want, or no characters, followed by a semicolon, open curly brace, close curly brace, and then the end of line. Okay. What's this one looking for?
The alphabet, either lowercase or uppercase with the beginning of A, or A through Z pretty much.
And? Ooh,
Uh,
it's got it.
Yep.
Words of 5 letters. And Kaya says any 5 characters at the beginning or end of a line. So, folks, I apologize. I'm not always remembering to look at the chat. I will try very hard to do better. So, beginning or end of a line and only 5 letters. So this one doesn't work unless I were to put an extra S on there, which makes it a misspelling, but it actually matches still. If I put a space in front of this, it's no longer a match, because it's got to be 5 characters at the beginning that goes to the end. Or 5 letters, yeah. Anyway, and then real quickly, I know we're at time. Let's take a look at this last one here. We'll cover modifiers tomorrow. Word boundaries. Lowercase b, beginnings and endings of word characters. And capital B, use negated word boundary or non-word boundaries. So let's try this out. So word boundary followed by special character lowercase w, which is a word character. And then we've also got a dash or an apostrophe. So since word characters don't normally have hyphens, we're adding the hyphen in there. And if there's an apostrophe in there, we're adding that too. And then as many characters, well, 1 or more characters. So what that's doing is that's grabbing words, just words. Even if there's a hyphen in it, or there's an apostrophe, like here, that regular expression is just grabbing any sort of word. Cool? View the diagram. It's got a word boundary. And word boundaries, oops, let me go back here. Word boundaries even include new lines. So long as there's a word boundary, you can then find any words. And just words. All right, are you all feeling like regular expressions experts now? Probably not.
Somewhat. It's still a bit confusing,
It
but
is.
I'm getting it.
It is. There's a lot to it. And again, it is not intuitive. Just looking at it, you're like, I mean, that's hideous. Let's be honest. As someone who really loves high-level languages, because they're very easy to read and easy to code, huge fan of JavaScript, Python, Ruby. I look at this and it makes me want to hurl. But if you understand it, it gives you so much power. And there's so many cool things that we can do with it. So we'll continue this tomorrow. We'll get through this, the modifiers, and then maybe we'll look at these examples and break them down and see how they work. Maybe we'll even write an example or two ourselves. We'll see. And then I got a new assignment for you. So if you have not turned in the trivia, please make sure it gets turned in. Okay? Cool. I will talk to you all later, unless anyone has any questions.
What is it? Is it this Friday, the Frex or something?
I think it might be. Frex is going to be a virtual Frex this year.
Yeah.
April 1. I do not know what sort of access current students will have. I know that there will be lots of videos where you can hear from different department chairs talking about Newmont. I think Ben Fletcher is going to be doing some sort of tour of Newmont. I don't know anything else about it. Hopefully some emails may come out if there is some way that you all are able to participate. I'm not sure.
There
Okay.
was a little bit of info in the like what's going on this week email thing that they send out.
Okay.
I know that they're going to be playing. Mr. Krebs and Mr. Evans are going to be playing Call of Duty Warfare, I believe it was,
Cool.
that we can take part in. They'll be sending out a sign-up sheet later this week for it.
Nice.
I don't know about anything other than that though.
Okay. Well, so you can play Call of Duty with Mr. Krebs and Mr. Evans.
Okay.
I don't play Call of Duty, and I'd rather not get schooled by them.
That was my only question. I wasn't completely sure about it still, but
Okay.
I shall see you hopefully tomorrow.
Yes. Good luck on your travels.
Hasta luego.
Take care. Let's see.